have not arrived, but you can walk your students out to the front entry and there are signs. for
Hello,
those
guys.
buses
So today
outside.
we are going to be
Again,
talking
you can
about,
that the buses
excuse me, we're going to be
outside.
using the concept mastery routine, which you guys should know about. I will review it in a second, but we'll be using that to talk about types of energy today. Specifically, we're going to talk about kinetic energy. I know we've talked about potential energy in the past, previous lessons. Today, we're going to talk about kinetic energy and how that is the same or comparable to potential and how it differs as well. So first off, this is going to look really familiar. This is our concept map diagram, part of the concept mastery routine. Concept mastery routine looks like this. If you guys can remember, it's always up on our board. We convey the concept name. I will offer the overall concept. We'll go through the keywords, classify characteristics, what's always, sometimes, and never present. We'll talk about our examples. We'll tie down a definition after our examples, and then we'll have this awesome sheet that can walk us through kinetic energy. We can use it as studying. We can use it for lots of different things. So, like I said, last time we talked about potential energy. So if we're talking about kinetic energy today, we kind of need an overall concept. So what might be, if we're talking about potential energy before, kinetic energy today, what might be an overall theme that would have both of those kind of together?
Energy?
Energy, yeah, or different kinds of
Different kinds
energy,
of energy.
types of energy. Yeah, just energy in general. We're talking about the different types. So I'm going to put something like types of energy. That way we know we're talking about energy, but different kinds and how they can be the same or how they can be different. So if last time we talked about potential, this time, do you remember what I said we're talking about? Starts with the K.
Kinetic
Energy, you got it. So that is the concept we're going to talk about today, kinetic energy. So first, we're going to think back to our lesson before, and we're going to think about some key terms that are going to help us talking about energy. There's lots of stuff that we talked about last time with potential energy. I'm going to give you one right now, and maybe it'll help spark your memory a little bit, but we're talking about like a body of mass or an object, right? Something that has energy. Energy has to be put into something. So there's going to be an object or a body of mass. Body of mass, remember, is just something that takes up space. So it could be an object or anything. We'll put body of mass there. Anything else you can think about when you think about energy? Do you think about movement? Do you think about staying still? What kind of stuff might you think about? Do you think about
I would say movement.
Movement or motion?
Yeah, motion.
Sure, yeah, motion. Another one that I'm going to add, I'm going to put motion in here. I like that. Another one that I think is just like that, motion and movement, is acceleration, right?
Mm-hmm.
Something is moving forward, but it takes acceleration and something to get that going. And that is acceleration. So that kind of goes right along with motion there, motion and acceleration. Another one that we talked about last time is velocity. Do you guys remember that? The velocity of something and how fast it is moving is another key term, especially when it comes to energy. And especially you'll see when it comes to kinetic energy, because kinetic energy has a little bit more to do with movement than potential energy did when we had it last week. So I'm thinking if there's anything else. I do think that we should have potential energy up here as one of our keywords, since we learned that before, and we'd like to know how that may be different or the same as this. We need to know that as one of our key terms. And the last one that I'm going to put on here that we'll talk a little bit about is stored energy. And that is also like potential energy. I forgot the G. But it's a little bit different. So those are some keywords. If you don't have them written down, make sure they're written down. Make sure you got a rough idea of kind of what they are and how they might work with kinetic energy. So now we have to think about characteristics of kinetic energy and what kinetic energy is, okay? So potential energy, as we know before, potential energy is energy that we have to put into something for it to go, okay? Kinetic energy is something is basically is movement or acceleration, whereas potential energy is something that could just be stored in it already. So if we're talking about kinetic energy, one thing that when it comes to energy, it was the first thing I wrote under the key terms. What is always present in energy? There always has to be this present.
There has to be a body of
A
mass.
body of mass, right? An object, a body of mass, a person, some sort of thing. So always present is going to be, I'm just going to put body of mass because I want you guys to remember that the body of mass can be anything, an object, anything, but there always has to be something for there. If we can't see anything, there can't be energy in that, or we don't know. There has to be an object or something, a race car. It could be anything, but there has to be an object or a body of mass. Okay, the other big one that I talked about that the second couple terms here that we talked about with kinetic energy and where it differs from potential is movement or motion. And you guys told me that already or talked about movement. So in kinetic energy, there's always motion. Something is always moving. It's going to start somewhere and it's going to move somewhere. So there's always motion or movement. You could put, I'm going to put motion because it's a little shorter word to put there. So there's always motion. With kinetic energy as well, it is going to start somewhere and stop somewhere. So do you think that where it starts, it's already moving, or maybe it stopped and then it moves and it stops again? What would you think?
I think it moves and then stops again.
Exactly. Yeah. So it's going to basically go from, as they talk it, from rest to acceleration. So something is in a resting mode, could be a soccer ball, could be a lot of different things, could be a car, and it is going to accelerate and move to a different destination. So something that's always going to be present is rest to acceleration. So we'll write rest to, I'm going to write excel with a period just for acceleration. So there's always movement, but it's always going from stopped, moving, and then stopping again. There's acceleration, so it's speeding up and then it's going to slow back down. So that is part of kinetic energy. Rest to acceleration, or from rest to, excuse me, rest, you know what, I messed that up. It's from rest to velocity. And that is, or started velocity. So what that means is it's from rest to its starting speed. It has to accelerate. So that is one that's always happening. There's always acceleration, but the acceleration happens from rest to velocity. So there always has to be a rest to the top speed, and within that, it accelerates to get up to that. Excuse me for that mistake there, but those things are always present. There's also some things that are going to be sometimes present. These are going to be kind of tricky to figure out with kinetic energy. So there's one thing that I'll help you out with, that there could be energy conversion. Let's say you kick a soccer ball and that soccer ball rolls really hard and it hits another ball. Does that other ball move?
Yes.
It does. So did the energy go from one ball to the next ball?
Yeah.
Right. So energy conversion, it hit something else and it pushed the energy into that and it converted its energy into a different object. So sometimes there can be energy conversion if it collides with something or if it hits something else in conversions. So with that being said, if there's energy conversion, the energy has to move from something to another. There's a T word when we talk about it, moving to something else. Can you think about that T word? The energy has to
transfer.
Yeah, so sometimes there can also be energy conversion where the energy converts to something else, but the energy has to transfer. So there could be an energy transfer within that kinetic energy that's happening as well. But it doesn't always necessarily happen because it might not hit something. It might just go excel and then rest, and then there wouldn't be any energy transfer. The last thing that possibly could be part of it too is there could be potential energy within that kinetic energy. Potential energy is potentially there from, we'll get into the examples that you can see, but there can be potential energy as well within that kinetic energy. So one thing that is never present in kinetic energy, and there's only one really big thing, and like I said, since it has to go from rest to velocity, there isn't going to be something that's already in there which is our word stored. Stored energy, there isn't any energy in that soccer ball already, right? It's just there. If there was stored energy, it might go even further when you kick it, but it's not. It only is kinetic energy, which is rest to velocity. So there's never going to be stored energy in kinetic energy. So that's kind of our never present. So if you ever think that there's stored energy or there's already energy within, it's not going to be kinetic energy, okay? So examples, I'm going to give a couple examples and I want you to guess or look at the, not guess, but take an educated guess and tell me if you think it's an example of kinetic energy or a non-example. So let's start with a bicycle on top of a hill going down. Do you think that would be kinetic energy or not?
Yes.
See, this one's kind of a tricky one. Since the bicycle is on top of the hill, think about it. If someone gets on it, do they have to pedal for it to move?
No.
No, it just goes. So they didn't put
Okay.
any motion into it or acceleration or energy. They didn't put any energy. So technically that one, if it were someone riding a bicycle, you're right, it would be kinetic energy. But a bike,
So if it's on a hill, it's not.
exactly, on a hill is what makes it a non-example. If we talk about someone throwing a frisbee, would that be an example or a non-example?
I think that would be an example.
An example, right? They're holding it, it's not moving, they throw it, they put energy in, and it excels, and then it stops. So, all right, frisbee. How about a battery? Maybe that you would put in a flashlight. Would that have kinetic energy in it, or would that have a different type of energy?
I think it would have a different type of energy.
You're right, a battery, because a battery doesn't move much, but it gives something power and energy. It actually has stored energy in it. And when you think about stored energy, is never present. So a battery is going to be a non-example. How about a speedboat? A speedboat is sitting there and someone goes and presses the engine and it goes. Is that kinetic energy?
I would say yes.
You got it. That one is pretty self-explanatory and a great example. How about an apple falling from a tree? So the apple is at a standstill hanging there and then it drops and it falls and then it stops when it hits the ground. Would that be kinetic energy?
I think so.
Yeah, it's a little tricky because it's gravity pulling it down, but it is. There's no stored energy in the apple when it's sitting up there, but when it falls, it excels and then it stops. So you're right. A falling apple. Definitely be an example. And our last one, this is a little tricky. A pogo stick pushed down. So it's already pushed down and it's a pogo stick. Is that going to have a kinetic energy in it or a different type of energy in it?
I would say a different type of energy.
You're right, because a pogo stick has a spring on it, right? So when you step on it, you are putting energy into it. And if it's pushed down already, there's some stored energy and it wants to come back. So because it's already pushed down, right, pogo stick, because it's already pushed down, that would have stored energy in it already. So now that we kind of have an idea, we've got some good examples and stuff. What might be some things that you would want to include in a definition for kinetic energy?
I would say that kinetic energy is a body of mass that goes from rest to velocity. Something to do with motion, but I'm not sure. That
Sure.
moves from rest to velocity, maybe?
So kinetic energy is energy that, what did you say, that moves from rest to velocity
Maybe through acceleration?
through acceleration. I love it. And the thing I love about this is that it says kinetic energy is energy that moves. It has the word move in it. We don't need to say kinetic energy is motion or make that clear because it says it moves, but it moves from rest to velocity and it gets there through acceleration. I think that's a great definition. There can be lots of different definitions, but I think this is great for us today. So if you do not have this filled out, I'll leave it up here for a few minutes. Please make sure you get it filled out as this will be a great study resource for you guys. So just to review, kinetic energy is a type of energy, body of mass, motion, acceleration, all has to occur. Other types of energy conversion or transfer could possibly occur, but there's never stored energy. We have our examples, and as long as no one has any questions, we can move on to our next activity. Any questions, guys?
Nope.
Lovely. Okay, we'll move on to our next activity. Please keep this in a safe place, and we'll move on. Thanks, guys. All right, stop.